We are asked to find the exact values of the missing side lengths in these special right triangles. We will first look at the two triangles that represent 30, 60, 90 triangles. In a 30, 60, 90 right triangle, we know that the length of the shortest side, A, is opposite the smallest angle, which is 30 degrees. We also know that A is 1/2 the length of the hypotenuse. We could also find this value for A by using our trig identities. If we are looking for the opposite of angle theta given the hypotenuse, then we are looking at a sine relationship. Therefore, the sine of 30 degrees is given by A over 4, or 4 times the sine of 30 degrees is given by A. We will know that the sine of 30 degrees is equal to 1/2, giving us A of 2, which again tells us that the shortest side is 1/2 the length of the hypotenuse. We can find length B by either using our sine relationship or our cosine relationship. We will recognize if we used cosine, we'll have the cosine of 30 is equal to B over 4, or 4 times the cosine of 30 degrees is equal to B. Cosine of 30 degrees is the square root of 3 over 2. Giving us B is equal to 2 times the square root of 3. In our other 30, 60, 90 triangle, we can do the same thing. We can recognize using 60 degrees that the sine of 60 degrees is equal to the opposite over the hypotenuse. Giving us C is equal to 3 divided by the sine of 60 degrees. We know the sine of 60 degrees is the square root of 3 over 2. Which can be rewritten as 6 divided by the square root of 3. We can simplify this by multiplying both sides by the square root of 3. Therefore, we get C is equal to the square root of 3 times 6 all over 3, which is equal to 2 times the square root of 3. We are now ready to solve for A. We could also recognize that A is that shortest side of the 30, 60, 90 triangle, which is 1/2 the length of the hypotenuse, so we should get A to be the square root of 3. We can use trig in order to verify this. We will know that we could take the cosine of 60 degrees is the adjacent over the hypotenuse. We know that the cosine of 60 degrees is 1/2, so now we have 2 times the square root of 3 times 1/2 is equal to A, or A is equal to the square root of 3. Finally, we'll look at our middle structure, our 45, 45, 90 triangle. We will know that the two legs have to be the same length, so B is equal to 7. In order to solve for C, we will recognize that the tangent of 45 degrees is equal to the opposite over the adjacent, which is equal to 1. We also know that the cosine of 45 degrees is equal to the adjacent over the hypotenuse.